Welcome back to Teaching Statistical Thinking. Last time, we learned how to analyze the distribution of a categorical and numerical variable by looking at bar charts, box plots, and histograms. Today, we will examine the relationship between two categorical variables. Now first, let's go back into the Joey Votto dataset. As a discerning Reds fan, I want to look just beyond the regular wins and losses. I'm curious how the Reds did against good competition. Let's see how many times they won and lost against teams that made the playoffs and those that did not make the playoffs, because that'll show how the Reds performed against top teams. So we'll go to Analyze, fit Y by X, and we'll put whether or not the opponent the Reds played, made the playoffs as the X factor, and whether or not the Reds won or lost each game as the Y response. And we're going to click OK. And quickly, let's close up the test because we're not going to worry about that today. This is a mosaic plot and a contingency table, which gives us a lot of information about the relationship between these two variables. First, let's just look at this top part. The mosaic plot shows us a graphical representation of much information. To begin, the relative width of the Y and N columns, and that's the yes or no, represents the relative frequency of the two outcomes. For example, because the no column seems a bit wider than the yes column, it's safe to conclude that the Reds played more teams that did not make the playoffs. The little vertical bar strip on the right side shows the overall proportional breakdown of wins and losses. Because the win segment is a bit longer than the L segment, we can conclude that the Reds won more games than they lost. Now, looking at just the left half of the chart will tell us how the Reds performed against teams who did not make the playoffs. From looking at the line that splits the boxes, we see that the Reds lost about 40% of the games, and therefore won about 60% of them. Likewise, for teams that made the playoffs, it looks like the Reds lost about 55% of the games and won 45% of the games. Now we're going to look at this table of values called a contingency table. The contingency table provides numerical values for all of the information we previously estimated. To find a box of interest, find where two outcomes you want match up. Let's find the information of where the Reds played a non-playoff team and won. So that would be this box here. The first number, 63, is how many times this scenario happened. The box lowest and furthest to the right is always the total number of observations, which is 162 because the Reds played 162 games. The second number says what percentage of the total number of observations the box contains. This would be 63 over 162, or 39%. The third number is the column percent of observations. So this tells us, only looking at the game the Reds won, what percentage came against teams that did not make the playoffs. This is calculated by dividing 63 by 90, which would give 70%. Because we know that of all the Reds' wins, 70% came against teams that did not make the playoffs, we also therefore know that 30% of the Reds' wins came against teams that did make the playoffs. All of the column percentages and the row percentages will add up to 100%. The fourth number is the row percent of observations. This number means the Reds won 62% of all the games they played against teams that did not make the playoffs. And likewise, from this we can tell that the Reds lost 38% of the games they played against teams that did not make the playoffs. The bottom columns, and the ones on the right here, are summation boxes. For example, this 102 says how many times the Reds played teams that did not make the playoffs, and they played 60 games against teams that did make the playoffs, and here the Reds won 90 games and lost 72. And these percentages here show this means the Reds played 63% of their games against teams that did not make the playoffs. So this gives the information in both observational counts and proportionality. So though we've discovered that the Reds had a successful 2013 season because they had more wins than losses, They did much worse against teams that did make the playoffs, that did not make the playoffs. So that's definitely something they should look to improve on in subsequent years. And that's about it for mosaic plots and contingency tables, although it does seem a little complicated at first. Again, we've proven that just sticking with it and really using our common sense to figure out how these proportions add up is extremely useful. Mosaic plots and contingency tables can be used for variables that have more than two categories. Although these may look more complicated, the rows will always add up to 100%, as will the columns. The next video will examine the relationship between one categorical or nominal variable and one numerical variable. Thank you for watching.